Assalamu Alaikum. My name is Shumas and you are watching my YouTube channel. In this video, we will see that how we can convert sulfur into sulfur dioxide and then sulfur into sulfur trioxide using two conversion reactors separately. So let's start. First of all, this question has been taken from himmalblau chapter 3 and its SAT section 3.5 3.5 SAT section. So as this question was on two pages, so I had just uh, written on a page for you. So this is the question. We have air sulfur, which is in the question it is written that it is 100 kg or 100 pound, but I had taken 100 kg. So 10% or 10% will sulfur will remain unconverted, or we will get it as unconverted. So 90% sulfur will convert to sulfur dioxide as it is written over here. Now after the burner, the composition of gases will be it is unknown. We have to find it. We will do it in Aspen Hysys, and then again we have applied a converter, which is again a conversion reactor, to convert SO3 into SO2 sorry into SO3, sulfur dioxide into sulfur trioxide, while some oxygen and nitrogen will remain unreacted. uh, sorry, nitrogen will remain unreacted because it is inert. So we will also find in aspenisis that what is the moles, total number of moles, that is represented by P1 and P2. So the temperature has been given 25 degree, pressure I had taken 101.2325 kPa. I had forgotten to write, sorry for that. And in this, if you apply the mole balance, you will see you will apply the balance and find the degree of freedom. You will know that we have the degree of freedom will come as 1, and you can say that it will be not equal to 0. So I had back calculate and find the air by the 100. It was given to us that 100% excess air was given. So I write the firstly I find the required air by from the balanced stoichiometric equations. Then I put it in the formula and calculated excess air. So if you have gone through mass balance, you can easily find the mass balance subject, so you can easily find the air entering, air required. So it is not a big problem. I had just back calculated and written air as, with 100% excess air, the kg moles of air will be 29.76. So I will now go to my simulation mode. So I am here in my simulation mode. I will just add my components. So the components are oxygen, nitrogen, sulfur. When you take sulfur amorphous, after this uh, I need SO3 and SO2 as well. So that's all for my components happening. I will go to the fluid package. So in the fluid package, you can see that as per in when we are dealing gases, so Penn Robinson is a very powerful and reliable fluid package. So I will select Penn Robinson. After this, we will go to the reactions and add reactions. So add reactions, the first reaction is sulfur is converted into sulfur dioxide. I will add reaction. It is also a conversion reaction, so I will just add reaction. I will click on this close, and now I will have to double click on the reaction button, uh, reaction 1. So our first reaction is sulfur is reacting with oxygen to produce sulfur dioxide. Now you want to have a balance equation. In balance equation, 1 mole of sulfur will react with 1 mole of oxygen to give 1 mole of sulfur dioxide. So I will write -1 for reactants. I will write minus with all the reactants and 1 with product. So it is a basic thing that Aspen Hysys understands that what is the reactants and what are products. So all the coefficients with minus sign, it will assume that these are reactants, and with no sign, it will assume that they are products. So now you can see that it is written that balance error is 0, my equation is balanced. Our base component is amorphous, and it is also a limiting reactant. We are giving oxygen in excess, as you have already seen in the given. We were having 100% excess here. In the conversion, I had told you that 100 kg of mole were fed, 10% remained unreactive. So the reaction conversion is 90%. So or 90%. So I will write here 90%. So that the our reaction is ready. Another thing, I will add this reaction to fluid package. So, but now a common mistake that people do, because in this we are having two reactions, but the second reaction is not happening in this reactor. It will happen in another reactor. So we will not click this add and add a reaction over here. It will lead to a very big problem. It will not calculate then. So if I will click add reaction, so it will add here another it will in the same set one you had added another reaction. So yeah, you can say that in the first conversion reactor, the Aspen Hysys will assume that two reactions are happening, but it is only one. Delete this reaction. For adding second, we have to add another set of reaction for another conversion reactor, because there are two conversion reactors in this problem. So I will add these reactions, and here I will, from set 1 I will add another set 2. After this set 2, here I will add the other reaction, that is sulfur dioxide is converted to sulfur trioxide. Again I will go through the same procedure. I am going through quickly. Sulfur dioxide reacted with oxygen to produce sulfur trioxide. 1 mole of sulfur dioxide will react with half mole of oxygen to give 1 mole of sulfur trioxide. That is the balance equation. It is balance error 0. Base component is again our SO2. For the conversion, it is given in the question that 95% of SO2 will convert into SO3. So I will write 95. Again OK, green signal, and I will add this reaction again to the fluid package. Now I will go to the simulation. Here I will select and drag a conversion reactor. Now in our streams we are having a sulfur stream, so I will write sulfur. Then I am having air stream, so I will write air. Here I am having unconverted sulfur in the bottom, because our reaction is 90% completed, so unconverted sulfur, and here I can write as P1, as it is given in the product 1. So when I will enter OK and press enter, it will say that requires a reaction set. So I will go to the reactions, and here I will add reaction set 1. So I had added reaction 1 set. So it is saying that not solved because I had not defined the streams. So I will go to the worksheet and define the streams. Temperature I will take as 25. So it is of sulfur. So sulfur at 25. Ambient temperature. Pressure I take as 101.325. And here I was given the mass flow rate. so I will write as 100 kg per hour, and I have to define its composition also. So again, a lot of tabs has been popped up, so I have to go through the sulfur composition tab. It is P1, so I will click cross unconverted air. So this is sulfur, and in this stream I am having 100% sulfur. So I will just click one on amorphous sulfur and OK. So now I will come to the air. Air also temperature is 25 because it is ambient temperature. For pressure I will take as 101.325. Now for air we are given with molar flow rate. So I know the molar flow rate, it was 29.76. So now I have to define its composition. So now in air the composition of oxygen is 0.21 and the composition of nitrogen is 0.79 by volume. So I will click it, and that's okay. So all the values and the problem has been solved. So in this you can see that our P1 is 29.76, and if you want to see the composition of gases, you will just click on the composition, and here you will calculate the composition of gases. You will 0.117 mole of sorry, composition of oxygen is 0.1157, composition of nitrogen is the same, SO2 is 0.09, and sulfur trioxide, no sulfur trioxide has been produced yet. So and if you want to see that how many moles of oxygen were entering and how many moles of oxygen has been produced, how many moles of sulfur were entering and how many moles of sulfur has been produced, and now how many sulfur moles have left unconverted, for this you have just go to reactions and select on results, and then click this reaction balance. So now you will see all this information, the total inlet moles that reacted and the total outflow moles that are not that are not reacted or gone unreacted. So now we will have to produce sulfur trioxide for sulfur dioxide. So we will take another conversion reactor, put it in front, and click on double click. So the stream entering is only of the gases, because in this we are sorry, the stream will be P1 because in this P1 we are having SO2, O2 and nitrogen. So I will just this stream. Now I will for sorry for that, wait. So for down liquid outlet I will just write down. For this vapor outlet I P2, in which we will be having SO2, SO3, oxygen and nitrogen. So when I press enter, it says requires a reaction set. So I will go to again reactions. Now I will select reaction set 2. So all things has been done. When I will double click this reactor, I can see that uh, the molar flow rate entering, molar flow rate of gases, and if I want to see the composition of gases, I can see from here. These are the composition of gases. So if we want to want to see that how many moles were entering and how many moles of has been produced and had gone unreacted. So again you will have to click results, then you have to click balance, balance reaction balance. Here you can see that the oxygen moles were in inflow of total moles of oxygen that reacted and total unreacted. So here you can see that in the start there was no SO3 produced, and at the end of the reaction 2.66 moles of SO3 has been produced. SO2 was 2.807 moles, out of which 2.6 has been reacted, and the left is or you can say that unconverted is 0.1403, that is only 5%, and of 0 2.807 95% has been converted to SO2. So I hope you like my video. Sorry for my English, it is a bit not up to the mark. I am trying. So please like, share and comment on my video. I will see you in my other video. Assalam Alaikum.